Well, I'd like to start things off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the Fisher Technic Education Division over here at Studica. And of course, today we're going to take a look at the newest release in the Fisher Technic line of simulation models, that being the Agile Production Simulation model, also known as APS. This new model is designed to demonstrate how the current challenges faced in production and logistics planning can be addressed. And it's designed to incorporate the best features of previous Fisher Technic models, along with many new cutting-edge innovations. So before we dive into the meat of the presentation, I'm just going to provide you with a bit of background on Fisher Technic and its products. The model we are examining today is once again the newest edition of the Fisher Technic line of industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. And the line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and in function how various automated robotic machines and systems commonly used in commercial manufacturing work and do their process. The Fisher Technic Company has been creating tools for teaching students of all ages about how technology works for almost 60 years now, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, the Fisher Technic system was created with more of an engineering mindset. The core building block used in the system is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts used in the system are designed to slide together and lock in place using a tongue and groove assembly method. And because they have hundreds of very different parts available, this will help technical builders to address very specific design needs. The Fisher Technic system was developed back in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations that are still used in both construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating Fisher Technic, Mr. Fisher was also noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. We've all used them. His company, the Fisher Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, many people are most familiar with Fisher Technic's line of construction sets, and which Studica also offers. And the focus of these building sets or construction sets, and it's whether those intended for the retail market or those designed for classroom use, in either case, the focus has always been on helping to foster an understanding of technology and again, how things work. The sets designed for use in the education sector are most often focused on a specific subject area, usually things that fall under the umbrella of what's now considered STEM education. So this is going to include sets that focus on topic areas such as mechanics, pneumatics, robotics, renewable energy, and so forth. Now, typically students would use these sets in the classroom and they'd be asked to build a progression of models using the unique Fisher Technic system, and then they perform various experiments which allow them to explore and understand key aspects of the subject being studied. Now, the line of Fisher Technic simulation solutions, which of course includes the model we're looking at in today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which again replicate in appearance and function various automated robotic machines and systems. Some of the models found in the Fisher Technic simulation line will include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high-bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fisher Technic also offers numerous variations of an integrated factory simulation model. Now, in the case of these factory simulation models, you'll usually have four or more individual workstations, such as, for example, you'd have a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, and they're all designed to work together as one self-contained material cycle. Now, other variations of the factory will focus on the idea of Factory 4.0, which utilizes IoT or the Internet of Things in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing each of these models in detail, I'm not going to touch on them here, but I would strongly urge anyone attending who'd be interested in finding out more to look up one of our upcoming presentations, or of course, you can reach out to me directly for more information, and I will provide details on that at the end of the presentation. Now, before we begin our overview of the new Agile Production Simulation model, let me very briefly outline some of the advantages of using Fisher-Technic's solutions. First, Fisher-Technic simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, again, in both appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and so on. And because of their compact size, they're not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and a very important one, is quality. Each Fisher-Technic simulation model is a hand-assembled, high-quality, German-made product. Now, the majority of the models in the Fisher-Technic simulation line, including, of course, the Agile Production Simulation model we're going to look at today, are 24-volt models which were designed specifically for use with the latest industry standard PLCs. Now, while the APS model that we're looking at today already includes all of the PLCs and all the necessary components within its scope of delivery, other Fisher-Technic 24-volt models can be controlled using the PLC of your choice, as well as the programming language that you prefer. Again, these models are designed specifically for use in higher education lab settings and for use in industrial commercial training facilities and classes. The most important point, Fisher-Technic simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll quickly notice that the entry point for many of these models can be quite high. Fisher-Technic simulation models, on the other hand, start at just a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. And while admittedly the new APS model is on the higher end of the Fisher-Technic product range, it still offers significant value in terms of what it allows you to address for a still very reasonable price point. And you would likely be very hard-pressed to find a truly comparable solution available currently at any price from any manufacturer. So with that being said, let's now move our discussion specifically to the Agile Production Simulation model and discussing what the term Agile Production means and why this is an important area. So here's a slide that I've used in several of the other Fisher-Technic focused webinars that we present, and this shows an early version of the Henry Ford style production line model. Now, the Ford production line model was in its own time a very innovative thing in that it streamlined up production back at a time when the focus was on efficiently producing a large quantity of the exact same thing. Now, in this case, workers along the assembly line each focused only on a specific part of the automobile production process. For example, focusing on installing a specific component or making a certain adjustment before the vehicle was moved further along the production line, where the next worker in line would perform the specific task that they were being charged with, and so on and so forth, until the assembly of each model automobile was completed. Again, when the goal was to produce a large quantity of the exact same thing, this worked really well. Of course, things are no longer quite so simple, and with good reason. Product customization must be considered, as well as the large numbers of assemblies and components that need to be used. Likewise, the increase in customization options which are available plays an important factor. Product life cycles are also much shorter now, with an increase in overlapping product launches and product production mix. And flexible manufacturing requires an increase in logistics processes. So to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex processes. And this requires companies to both synchronize production and logistics, to make investments in cutting-edge automation equipment and processes, and to be as efficient as possible. Now, as an example, consider the production of a modern automobile such as the BMW 3 Series, which is shown on your screen right now. Now, the manufacturing process must be set up to efficiently and cost-effectively address the 18 different engine options available to consumers of this product, as well as the 5 different equipment packages and 70 different individual equipment options. Now, clearly, the old school Henry Ford style assembly line, which again was designed to quickly produce a high quantity of a single specific model, simply will not work in this instance. It is with this in mind that industry has increasingly transitioned again from the assembly line production method with its rigidity and constraints to methods such as the matrix production model, which eliminates the fixed time cycle and sequence of processes, or fluid production models, which also allows for an unlimited number of assembly scopes per station. The most notable benefits of incorporating such agile production methods are in the area of flexibility, including the increased flexibility in production processes, being able to off customer specific mass production while avoiding overcapacity, and also reducing lead time through a mix of different derivatives. An additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. And this is why Fisher Technic created the new Agile Production Simulation, which again is the latest version of the Fisher Technic factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI. In addition, this innovative new model also includes a digital learning platform. So here's a quick look at the full factory. Now, as we've just seen, forward-thinking companies rely on automation, modularity, artificial intelligence, and agility to remain competitive. So in order to promote these topics in industry and research, students, apprentices, and employees each require the corresponding know-how and awareness to enable them to deal with these complex issues. And this is where the Fisher Technic Agile Production Simulation model comes in. It's designed to simulate processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and to replicate automated processes on a small scale, from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the Fisher Technic simulation line, including an automated guided vehicle and a 6-axis robot. The accompanying didactic materials help to translate the hands-on simulated processes into future skills for both students and teachers. And in addition, the digital twin of the model helps to significantly intensify the learning experience. Now, as we are still awaiting the release of a fully narrated video for the factory, I'm going to provide you with an overview of briefly of each of the workstations or modules, beginning with the section where the incoming and outgoing goods are placed. And this is, of course, where the material flow of a workpiece begins and ends. The raw material is delivered at the goods receipt slot. It's positioned on the color sensor as shown here for quality assurance control using the 6-axis robot arm with vacuum gripper, and it's then encoded on the NFC reader. Now, the 6-axis robot then places the workpiece we just saw onto the automated guided vehicle, or AGV, for further transport. Now, this module also contains the central control unit, the Raspberry Pi unit, and the environmental sensor, which is used to measure the different environmental conditions for the factory. Now, there's also an integrated movable camera, which can be swiveled in 2 axes and provides an insight into the entire factory via the Fisher Technic Cloud dashboard, which we saw an example of in our previous factory video if you've seen the other presentation. Now, at the end of a cycle, a finished workpiece is delivered back to the goods dispatch by the AGV. So normally, the next step for a workpiece after the goods receipt, after the first station we saw where it's scanned and it goes on to the AGV, the first station that it could go to is usually the high bay warehouse. Although, again, because this is designed to be an agile production simulation, the order of processes, the order of the stations that the AGV will go to can be changed if there's a need for doing so. But in any case, the high bay warehouse contains 9 slots for workpieces. It contains its own stacker crane and a vacuum gripper that picks up the workpiece from the AGV at the docking station and hands it over to the stacker crane for storage. The workpiece is placed in a workpiece carrier for storage, and then retrieval is done according to the first in, first out principle as pieces are needed. The next model we can look at is the drilling station. The drilling station consists of a docking station for the AGV. It has a vacuum gripper that places the workpiece onto a conveyor belt from the AGV from where it is transported under the drilling head. Now, after the simulated drilling process occurs, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places the workpiece back onto the AGV. Next up is the milling station. Now, on a side note, as I have not mentioned it previously in our presentation, you will notice that the high bay warehouse, the drilling station, the milling station, and the station for ingoing and outgoing workpieces, and the next station we're going to be looking at as well, each come pre-wired to a Siemens S7 1200 PLC, which has been pre-programmed. I just want to mention that now, but we're of course going to touch on it a bit later in the presentation, but just because you're obviously seeing that in the pictures. So continuing along, the milling station consists of a docking station for the AGV and a vacuum gripper again that places the workpiece from the AGV onto a conveyor belt from where it is transported under the milling machine. There, the milling of 2 pockets is simulated on the workpiece. And after this process is completed, the workpiece is placed back onto the conveyor belt, and then it's transported back to the vacuum gripper for this model, and the gripper then places it onto the automated guided vehicle. Next up is the quality control with AI module. Now, in the quality control module, a vacuum gripper, again, places the workpiece on a conveyor belt from the AGV, and it is then transported underneath the camera and it's scanned. The workpieces, which come in 3 different colors, red, white, and blue, also have 3 machining features printed on there. So it could have characteristics for drilling, and milling, as well as various fault patterns. And these are all classified using the trained AI after they've been scanned. Now, depending on the color, the feature, or the fault pattern, the workpieces are then either placed back onto the AGV as being acceptable, okay, or they're sent to a reject container as not okay or defective. And just to provide a little more information on the AGV we've been looking at is, of course, the module which transports, again, the workpieces from one of these workstations to another. It's controlled by a Fisher Technic Robotics TXT controller, which has been pre-programmed using Python. Now, it's a track-based vehicle that follows the printed black tracks that are shown on the factory floor. Now, it uses ultrasonic sensors to detect obstacles that might be in its way. And the vehicle also has omni wheels, which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle dock to individual factory modules. The AGV receives its driving commands from the central control unit, which is an industrial standard VDE 5050. And it does use a Fisher Technic rechargeable battery pack as its power supply. Which brings us to the charging station. Now, when the battery of the AGV runs low, it navigates towards the charging station, where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station connect the AGV with the charging elements. Moving right along, let's just quickly review some of the technical specifications. You have a 24-volt power unit, 11 amps. A central control unit is the Raspberry Pi 4B. You have individual models that are controlled with the help of 5 SPS Siemens S7 1200 PLCs. Additionally, the model includes 3 Fisher-Technic TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to facilitate cloud access in the WEWA module for quality assurance with AI, as well as for automated guided vehicles. There's, of course, a WLAN router for the WLAN network. Software used on the APS model includes SPS programs, structured text for the PLCs, TypeScript for central control of the Raspberry Pi, Node-RED for communication between the SPS and the Fisher-Technic TXT 4.0 controllers, Python for programs on the TXT 4.0 controllers, TensorFlow for supervised learning and quality assurance with AI. Now, additionally, like the most recent versions of the Fisher-Technic Training Factory that we've discussed in our other webinar presentation, the APS model also has a cloud-based dashboard, which can be used for order control and monitoring of the factory status, as well as for determining key figures. The factory itself can be broken down into sections which utilize an easy-to-put-together tongue-and-groove assembly like giant puzzle pieces. Now, when assembled, the Agile Production Simulation model has a footprint of approximately 51 by 73 inches, and it has a total weight of approximately 116 pounds. A storage case is available separately for protecting the model when not in use or when being transported, and of course, we're going to look at that shortly. And again, didactic materials are also included in the scope of delivery. Now, as I mentioned earlier in the presentation, we're still waiting the completion of a narrated video of the factory in motion, but while that is not yet available, I would like to share this raw video that we have of the factory in operation. You will see it going through the motion of various steps that I touched upon earlier, so let's start this up. So here you see the AGV is in motion. Again, moving along the black pre-printed track on the factory floor. That's the TXT 4.0 controller. You see as it docks with the station. The camera, of course, for monitoring things. The web-based dashboard, the environmental sensors, monitoring temperature, air quality, air pressure, etc., light. This is the station where work pieces are entered into the process. The vacuum gripper at the workpiece or at the station will move it on to the reader. And once it's been accepted into the system, then it goes from there to the AGV to be transported to the various workstations where the processes have to be completed. In this case, just like the order of the description that we went through before, the AGV has gone first off to the automated high bay warehouse where the crane at that location picks up the workpiece, moves it into the carrier tray where it can be stored into one of the 9 slots that are available at the high bay warehouse. And again, things are retrieved in a first in, first out method. There you see the web-based dashboard tracking what pieces are in the warehouse. White, blue, red. Again, you see a workpiece being retrieved. Going back where it's retrieved by the gripper and put back into the AGV for movement to the next workstation. Again, we have the crane at the new workstation, picking up the workpiece from the AGV, moving it onto the little conveyor belt. In this case, you're going through a drilling process here. Then AGV going off to next station. In this case, you're going to the AI module. And this is where the workpiece is being scanned, and it's going to be categorized, whether it's a good workpiece or a defective workpiece. Of course, if it's good workpiece, it goes back. If it was defective, it would get rejected. And here it is being scanned once again. And it's going back for now the workpiece could be picked up. And here you see the AGV docking to be recharged. We did skip a station in there somewhere. It did not do both the milling and the drilling station, but the processes are similar, of course. You can see how the floor of the factory comes apart here with each component taken apart like that. So there are sections which will have each of the workstations. So moving right along here, just a second. So another very important aspect of the APS model, which I touched upon at the beginning of the presentation, is of course the inclusion of a digital learning platform. Now, the digital learning platform is a high-performance immersive learning environment, and it's based on a digital twin of the Agile Production Simulation. Now, this serves as the educational counterpart to the physical factory model. This learning tool is used to clearly illustrate the control units, the actuators, and sensors included on the model, and to demonstrate the full functionality of the APS. This platform offers interactive learning modules on agile manufacturing, IoT, AI, and automation. It enables the simulation and evaluation of highly complex process workflows in agile production or agile manufacturing. The digital learning platform is a byproduct of the partnership between Fischer Technic Germany and the Karlsruhe, Institute of Technology in Germany, the prestigious public research university that's located in Karlsruhe. And please note that there are no additional costs or fees associated with this material. It is included in the scope of delivery when you purchase the APS. Now, to give you a better idea, this page helps to illustrate the structure of what is being covered by the digital learning platform. Now, as you can see here, users start with an introduction to the Agile Production Simulation. This begins with an interactive explanation of each of the process modules, as well as of the control units, the actuators, and the sensors being used. Following this, the main instruction is broken up into 4 separate modules. One is focused on agile manufacturing, the second on the Internet of Things or IoT, the third on artificial intelligence, and the last on automation. Each unit or learning module includes the following: a theory section, establishing a fundamental understanding of the topic at hand. 2, a practice session, and this is where users can simulate and understand the processes being studied with both the physical mode and the digital twin mode. And finally, transferability, where students get to see how the knowledge they've acquired can be used in the real world. Now, here are some screen captures of the digital learning platform just to provide a better idea of what this is all about. The digital twin forms the foundation of the digital learning platform. And once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules. And the digital twin can be used to simulate complex challenges in an agile production environment. We'll just look at some of these things. And in the next one, I believe you're going to have a little narration, and so I'm going to let them talk.
There are 4 different learning modules: Agile Production, Internet of Things, Artificial Intelligence, and Automation. There's always a theory introduction. On the right side, you can find the different tasks. We visualized the difficulty of the tasks and the platform.
And that may be it. Okay, thought they had a little more there. Now you will see there are a lot of tools with the DLP, including this workflow planner tool and an analysis tool as well. Now, if you want to delve further into this, you can do so by simply emailing me, and I'll be happy to provide my contact info at the end of this presentation. And if you do reach out to me, I'll be happy to send you a link to the specific section of the manufacturer's website where more detailed information and system requirements on all of this are posted. Flexible, modular, agile, and connected. Essentially, that's the Fisher-Technic Agile Production Simulation model. The APS model is the perfect tool to use in higher education, to use for advanced CTE training, university labs, and for industrial training. It's an ideal tool for teaching about the future of production, and it offers a hands-on learning experience. It provides a safe method for teaching these skills while also offering a tool that replicates, again, in both appearance and in function, those tools that would be used in industry. It provides a bird's eye view of a working factory, and of course, it offers considerable added value with the digital learning platform being included. It's also ideal for demonstration purposes for companies involved in areas such as IT and software development, as well as for consulting. In addition to the APS factory itself, there are now 2 add-on modules, which can also be incorporated if one wishes to expand the functionality of the model. The additional annealing furnace production module unlocks more learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing learning module are made available. These cover topics such as introducing new derivatives into production and expanding existing production configurations with an additional process. Now, the module, like most of the modules of the APS, again includes its own Siemens S7-1200 PLC, which has been pre-programmed in structured text. Now, as an FYI, the annealing furnace module has dimensions of approximately 22.5 by 15 by 9 inches, and it has a weight on its own of about 10 pounds. It is, of course, designed specifically for use in combination with the APS model and not as a freestanding workstation. The second add-on available for purchase, as I touched upon before, is an additional AGV, which can also be used it can be added to your model. Now, like the annealing furnace, the add-on automated guided vehicle also unlocks access to further learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available, and these focus on agile intralogistics as well as the parallelization and prioritization of the production workflow. Now, the model ships with a pre-programmed Fisher-Technic's Robotics TXT 4.0 controller, as with the version included within the APS. The program, as with the version included in the APS, the programming is in Python. Now, can of course only be used in combination with the APS model. It's again not intended for freestanding use. The dimensions for the model are approximately 10 by 7 by 5.5 inches, and it has a weight of about 3.5 pounds. Now, as that concludes the main portion of our overview of the Fisher-Technic Agile Production Simulation model, we're going to now look at the cost for each of these items. The Agile Production Simulation model, again including 5 Siemens S7-1200 PLCs and 3 Fisher-Technic TXT 4.0 controllers, as well as the digital learning platform with the digital twin, you're looking at a cost of $28,174.95 per unit. If you were looking at the APS add-on module, the annealing furnace, which again includes the Siemens S7-1200 PLC, and it unlocks additional didactic content in the digital learning platform. The cost for that is $3,859.95. If you were looking at the additional automated guided vehicle or AGV, which again also unlocks didactic content in the digital learning platform, the cost for an additional model is $2,249.95. The Agile Production Simulation storage case, this is a two-tier aluminum case that has foam inlays to protect the individual workstation modules. Uh, Now, as the APS is obviously a very substantial investment, this is a great option to help protect the model when not in use, and of course, when in transport, to just make sure that you're keeping it safe. The case has an aluminum case maker profile with plastic plates. Now, each of the two separate case sections has steel tilt handles and angle protection corners for additional stability. And there are also straps and there are various internal zipper pockets, excuse me, for storing cables, cords, work pieces, work trays, and other accessories. The lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules while in storage. The dimensions for this case are approximately 48 by 32 by 29 inches. It has a weight of approximately 75 pounds unloaded, and when the APS model is loaded into the case, the total weight is approximately 190 pounds. And again, please note that even when the model is being kept in storage, if you are transporting the model should always be shipped flat as freight on a pallet. The cost for the storage case separately is $4,024.95. So on that note, if you do have any questions, this would be the time to use the webinar chat window or the question and answer window that can be found on the Zoom toolbar. If not, and of course I will answer anything that might come up, but if not, if you would like to take the next step, now perhaps you would like to request the full color 2025 Fisher Technic Higher Education and Industry Guide, which we'd be happy to send you. If you would like to receive a formal quote on this model or any of the models we offer, you can do that as well. If you'd like to speak with your dedicated educational representative, depending on what state you're in, you can do all of those things by calling us directly. Our number here, toll free, is 888-561-7521. If you'd like to email us again for quotes or any of this information, you can email us at info@studica.com. Very easy to remember. Or if you would like to connect with me about any of the things we discussed today, if you would like to receive any of the research that I touched upon during the presentation, or any of the information that might be available, or information on any other models, you can just email me directly, lance.zurek, lance.zurek@studica.com. So on that note, thank you very much again for taking the time to attend today's presentation. We look forward to hearing from you soon. Take care.